So everything's better. Write down the name on the blackboard. Okay, reporter, you can start your presentation.
Hello everyone, my name is Dorothy from TYPT. The topic of my report today is problem number 16, total travel. In problem statement, place an object on a large air cushion and drop several other objects in such a way that the first object is totally away. Investigate how the velocity depends on the parameters. And in experiments, the method focuses on how the different rates of drop objects affect the velocity and the relationship between the gas volume in the cushion and also its velocity. And for the experiment video, we can see here we will use this object because the rope and the method. And so when they drop on the cushion, the object will fly right away. So here is about the calculation of velocity. So we can see the trajectory of the flying object in the experiment video previously mentioned. The trajectory is about projectile motion. So when it is flying, it will contain the velocity in horizontal and in vertical direction. So we can compare the two of the velocity here, and we can see both of them will accelerate for a short period of time because the force from the cushion will make it accelerate. And then the velocity will, due to the resistance, will slow down, and then it will reach its high point here, and which means the velocity will also be minimum. And then because of the gravity, the velocity will increase again in vertical direction. And here is about the inner cushion, and because cushion can be seen as a closed system, and so we can use some like other gas cushion to explain this, but it can only be like a more ideal situation. So we know R is a constant, and the modulus in the cushion will not change at the moment of impact. And here is about the detection of the temperature at the time of the impact. And so we can see temperature will not change a lot when the dropped object in the cushion. But while here is some little jumping, but it's not really affected a lot because it's only in 1 degree. And also, so before the dropped object hit the cushion, it will have the gravity, and then when it hits the cushion, the pressure will transform here. And also, so we can see next page. And so when the cushion, when the dropped object hit the cushion, it will develop a large indentation, and which will decrease the volume of the cushion. So which means the volume of the gas in it will also decrease, and the pressure here will increase. So we can see in the previous picture, here is about the detection of the pressure in the cushion, and we have a pipe to connect with it. So we can see the pressure will suddenly increase, and here the volume of the cushion will decrease. And also, if the dropped object has in the cushion the object, the airflow in it will be pushed away, and so other object will also be pushed by the air in the cushion. So, and here, because it hit here, so the air modulus will gather in here, and that's why it will be pushed away. Okay, so next is about the energy transformation. So before the dropped object in the cushion, it will store potential energy, and when it is dropped, the energy will be converted into kinetic energy. So the acceleration of it will and the force which will push the cushion. And so when it the mass of the flying object is controlled, so as the mass of the object increases, the velocity of flying object will also increase. And for the downhill path, because the height level increases is controlled and the mass of drop object is controlled, so the mass of the flying object and the velocity, they will have a negative correlation. And also we can see there's a large difference between ideal and experimental value, and also as the weight of object increases, the core difference will increase. So we have an explanation of this phenomenon, and because we think that information of 22 liter and the 22 liter means the gas volume in the cushion. So when the gas volume is less, which means the information of it when the gas volume here is less, which means it gets easier to deform. And while the gas volume is more, it gets hard to deform. And here, for this parameter, we use the one that with more gas volume. So I think that is the main reason why the larger that will cause the large difference between ideal and experimental value. So here we think that the increase of information will not be as much as the increase of rate. And that also there will be some introduced through the process. So here is the energy missing part. Also when the drop subject, before the drop subject in the cushion, and so when in the cushion, the air resistance will collapse remove, and also the air flowing it will move right, and so there will be some energy loss in the cushion, and so it will cause the work absorbed by the cushion, and that will be the energy loss. And also the pressure won't be fully converted to the position that the flying object is. So also when the flying object is flying, the air resistance will cause it not to reach its really highest point. And also we can see in some cases here that it will rotate during the process, so I think some rotational kinetic energy will also come to this. And for the next is about a hands-off drop subject. So we can see the results as the drop subject increases its velocity will also increase. So in here we can also use the energy conversion to explain this phenomenon. And next part is about the gas volume, and there are 4 kinds of gas volume. So we can see the velocity of flying object will be maximum when the gas volume is at 26 liters. And so we'll explain its phenomenon in the next page. And so when the gas volume is too low in the cushion, which means the surface is too loose, and the gas in it is cannot be hold the cushion. So some energy will be consumed in the deformation of the cushion, because the gas volume in it will get easier to deform. And when the gas volume is too much, the surface is too tight, which means it's harder to deform. So the deformation of drop junction that happens on the cushion may not be as much as the deformation of the other object here. So energy will be consumed by the cushion. So when it is just in right volume, the surface will not be too loose or too tight, so the one object can fly away. Okay, the next is about the distance between drops and one object. So we have 3 kinds of distance. And when the 2 objects is too closer, its velocity will decrease. So we think for this is because when 2 objects get closer, when the cushion, the air here will force in all directions. So which means the airflow is dispersed. And so the airflow may not can hit the position directly. So and when 2 objects are more separated, and when the jump object to the cushion, the airflow will be more concentrated. And so it can hit the cushion more directly, which will make its velocity bigger. And that is about different counter error in the same way. And when the counter error in the cushion increases, its velocity will also increase, because we see that the pressure in the cushion of the surface of the cushion is the same. So as the counter error increases, which means the more force will in conclusion, we think that the magnetic velocity increases because the weight of the drop object and the height of the drop object, and the counter error of flying object is increased.
consider the torque of the bag, the cushion itself? Yeah, like when it rotates, like when the cushion goes up and down, do you consider it? Please answer this one.
I think it can be
So no. Okay. And then did you consider different sizes of bags?
different size of
The cushion.
dog.
Okay. Do you consider the rebound of the object that you're dropping? Do you consider any rebound of the object you're dropping? Like when you drop, right? And when it hits the cushion, it might cause the drop object to go backward or like rebound anywhere, correct? Okay. And then do you consider any disforming force of the cushion itself? Like the balance. So you didn't consider any balancing of the cushion when it's filled with air, correct?
No, we don't consider it velocity.
So do you consider any moments when you only change the distance, the dropping location?
No, the cushion is controlled.
Okay. And then for the dropping object, did you consider any different shapes of the object you dropped?
No.
What was the shape of the launch object?
The launch, you mean the flying?
Yeah, the flying object. No, like what was the shape of it?
Yes,
So what was the shape? And then how do you guarantee the string doesn't move around when you cut it? In your experimental setup, how do you make sure that it doesn't swing around?
Yes.
So it's always there.
Yes,
Is energy loss quantified in your theory?
not really.
Okay.
We have the
So
comparison.
how did exit velocity give the x component, and how will it affect the cap edges?
Time to stop.
전탄 그래프를 언할 땐 내가 어디 포지션을 쓰는 것이 과연. So this is a problem place an object on the air, larger cushion and drop several other objects in such a way that the first object is catapulted away. Investigate how the exit velocity depends on different parameters. And this is the ideal structure of the investigations of the reporter should have performed. And step 1, there should be an observation of the phenomenon that affects the experiment. 2, they should identify the relevant parameters to this phenomenon and make theory regarding to these parameters. And 3, they should have the experimentation of the parameters. And lastly, they should have an analysis of their data with the theory developed. And this is a point structure of solving this problem. First, they had their phenomenal observations. For example, they had drop gas on the air cushion and analyzed the velocity. They analyzed the cushion as a closed system using temperature and pressure analysis using the ideal gas law. And they also considered energy transformation. And then they had the experimental setup. In their experimental setup, they explained that they put an object from a plastic to a spring. And then it hits a cushion and acts on a force sensor. And they compared the theoretical velocity and the actual velocity. And for analysis of their errors, they analyzed where energy is lost, which is caused by the deformation of the cushion. These are the pros and cons for the report. For the pros, they had a good representation of their experimental setup. Also, they had clear visuals for each stage of their experiment. And then they clearly showcased their theory using conservation of energy and displayed the theoretical line for it. And then they listed the parameters out and they controlled for drop location and the contact area of the drop location. For the cons, they didn't have error bars in their curve, so we didn't know if the data actually matches their theory. And then they had no improvement in their theory to account any different energy loss factors. And the time management of precision could be improved. They missed a lot of important parameters and other forms of energy loss. And these are the points of discussion I want to discuss during the discussion period. For topic 1, we have the data, which is a fitting of theory, error bars, and analysis. And topic 2, I'll talk about the experimental method of the reporter, considering the parameters, comparison of the importance of the parameters, location of drop, and the size of the cushion itself. And for topic 3, I'll be focusing on theory. And for theory, I'll be talking about torque, energy conservation, which is also energy dissipation, considering the equations for conservation of energy, and the types of energy loss that could be considered in the phenomenon investigation. And also, I'll be talking about work done on the cushion and ask them to compare the equation and the integration of air. So I'd like to go on to this. Okay, so firstly, can you go to your setup? Can I see your video for the setup? To explain the setup. As you can see in this video, you agree that when the drop object is a cushion, the cushion will lift having a certain amount of volume under the cushion, right? You agree? So also, can you see the object that's rebounding up after it drops? Yeah, the drop object. You agree that it goes up and rebounds. And do you agree that can be considered the law of conservation of energy?
Yes.
Did you put that in your theory explanation? Like you gave us a theory based on conservation of energy, correct? Yes. But did you consider that factor in your theory?
There probably only considered the ideal situation that is the energy of fully converted.
You go to Blackboard. So can you please write down the conservation of energy law that you consider all the factors that you consider? Yeah, like your theory on the conservation of energy. Yeah. So you only consider so you can to clarify, consider the potential energy of the drop object, right? Yes. You have energy H. Right? This equals to this only goes to the translation of kinetic energy of the second object, right? Do you consider any rotation of kinetic energy? And do you, I saw you did consider, but do you consider putting in your theory? Because the rotation, because you said this potential energy will fully transfer to this. Has translation kinetic energy. However, if you don't have I omega squared, which is the rotational kinetic energy of the second object, you would have like energy loss due to the factor of kinetic energy. Yeah. So why didn't you?
So you mean why
Not like put it in your. Also, you agree to my point that you should have considered it in your theory. Also. Yeah, it will be, due to the law, it should be considered. But I'm saying that there will be different factors that this will go into in your theory. And you're finding the exit velocity, which is the translational velocity. So if you consider the rotational velocity of the object that's getting launched, this will maybe have a better fit for your theory, since you also mentioned that your theory, yeah, and there's like there's a big gap due to energy loss. So move on to the next point. Can you like label all the energy loss that can be existing in your experiments? Yeah, because you said there's lots of energy loss, but they didn't really explain every single aspect of the energy loss, correct?
I think I have said that based on error resistance and the work resistance observed by the creatures, and also the error resistance of when they are objects, right?
Can you derive the equation for work done by the cushion? The work. Because you said work observed by the cushion. Do you have any quantitative theory or explanation?
I didn't talk about it.
Let me give you a solution. You said that the volume will change when since you said, let's say this is the cushion you have, and you drop the object, right? And since the force will be energy, right? And this is over the surface area, and this is the pressure, right? And this will be added onto overall pressure, causing higher pressure here. And in your theory, it's gonna that's what it's gonna do to and launch, correct? Here. And since pressure PV equals energy, use this in your equation. So having a larger pressure will decrease the volume. And what I want to suggest here is work done by the bag equals negative pressure integral PV initial and P final. And if you quantify the P final and P line, I'm pretty sure you can get the work done by the bag. And using the ideal gas law, since you said you're considering it's an ideal situation, so you can actually put this in as equal to negative nRT.
But the pressure is not pressure is in the closed situation and the of the gas, not the pressure of the force.
No, I'm saying no. This is an additional pressure, right? So I'm saying that like pressure. Let's say you have pressure in space, and you're saying that this object will increase the pressure at this point. Yeah, that's what I'm saying. This is the pressure addition plus this energy. This is the pressure I'm talking about in this situation. Do you understand? Yeah, and also doing this, I'll get this. So this is a qualitative theory I want to suggest to you, and maybe this will eventually can cause your error to be smaller, like since your theory was like that and your experimental balance here, right? So I think if you consider this what I suggested to you, I think you can close it. Yeah. Also, one thing I also want to ask, do you have the energy? Do you experience any sound in your experience?
Sound?
Yeah, like thinking of sound, like. So do you agree that sound would be an important factor?
No, I don't think
So what exactly do you think is an aspect of energy loss? Because you're saying sound is not, heat is not. What do you think? What do you think heat is? So what's the important factor?
The important is the deformation of the cushion.
So you're saying deformation of the cushion is causing the energy loss?
Yes. And also
Let's move on to our next point. The next point I want to talk about is the work of the system. So let's say this is your cushion, right? And as you see in that video, when you drop this object here, this will actually rebound up, right? And this creates some space. So you can assume that if can say that this cushion itself is rotating.
But I think it with the torque is not in the same, it's not the same position. You need a torque, so you must have the little part.
No, I'm saying this because this is rotating. There should be torque applied. Because in a rotate, you agree that this cushion will rotate or jump out.
Yes.
So wouldn't that create torque in the system?
So when you get the chair wheel,
Yeah, sure. You can also make like this part, this part, this part. That's lifted. And then since when you consider the torque, and there will be a pivot point where it rotates. Regarding to that, there will be a certain angle that it goes, and you have certain amount of force. Oh, you're exerting like the object will give a force to the cushion, correct? And that will cause the torque to like the rotation to happen. So you can use that to calculate the torque, and thus you can. I think that would be a better consideration than only considering conservation of energy in your theory. Since conservation, you can evidently see that your theory does not match your.
So I use different ways to observe the phenomenon. I don't think it can be. I mean, it's fine.
Oh, you're saying conservation of energy is fine, but you didn't without labeling any single factor of energy loss. We're giving a quantitative theory regarding to the theory. You're saying it's going to be correct. By only saying energy equals the translation of energy.
I think it's also fine to explain this phenomenon.
Oh, so, but
Yes, so do you think it can be this phenomenon?
no, I'm saying that it would, at like a preliminary experiment, you can consider this, and that's why I continue to explain why you should consider the rotation of energy, and also the work done from the cushion itself. This will also hold this energy and perform as a. I agree that my suggestion will further improve your experience. So do you agree to my suggestions? Do you,
Okay, I think it's okay, but I think you can focus on my prayer.
okay, sure. Then can we go to your class? That you're like on that. Would you have experience with the theory of hospital?
Yes.
This one is, do you have your mark? Is it like
Yes,
super big?
here.
You're saying that it's like really small, really small.
Here.
Also, I want to ask you to consider. So you know the total volume of the bag. Volume, like 100%. Like if you like you can't even put more air. Total volume, because you label like 36 liters, 32 liters, like. But it's 32 liters like the maximum amount of air.
Oh, you mentioned about gas oil.
Time to stop. To summarize.
So this is the summary of the discussion, and we mostly focus on your theoretical model. And to improve the theory, I recommended them to consider the work done on the cushion to be quantified, as you can see in that blackboard. And also they can consider rotational kinetic energy, which will be an important factor to consider this phenomenon. And also we talked about movement in the cushion, and yeah, you can also consider rotational energy to consider that. And we agree that energy is lost by deformation of cushion, where the ideal scenario where the cushion regains shape can help control the phenomena of deceleration. But they don't really focus on the energy loss. And some is general by cushion, and they clarify the error bars on the top mass track.
Thank you.
More visible is better.
So it's time for review. You have to.
So, good morning. I'm the reviewer of problem number 16. So, first I would like to ask the reporter which is the main factor affecting the exit velocity. What is the most significant one?
I think it's gas volume.
Okay, what do you think?
I think it's a mass loss.
Okay, so can I ask what is your material of the cushion?
Material?
Yes.
Rubber.
Oh, rubber. Okay. So, did you consider air resistance when you are releasing the ball?
I mentioned it is the energy losing part.
Okay. Okay. So, do you think you should consider it in your theory, or did you consider air resistance?
Well, I think it would be good to consider, but I think it's negligible.
Okay. So, did you only drop one object? Because the problem statement said that we have to drop several objects.
We have changed the weight of it.
Okay, it's fine. Skip this question. Due to your experience data, I can know that it shows that the longer the distance between the two objects, the bigger the velocity. Is it correct? Okay, so what do you think about it? The longer between two objects, the bigger exit velocity will. Okay. So what affects the contact time between when you drop it and then the contact time with the?
I think maybe because the volume of the cushion or the weight of the object.
Okay. So what do you think that the weight of the falling object will change the contact time?
Yes.
What do you think? Okay. So what causes the energy to lose the most?
I think it's the energy in the cushion.
The transfer in the
Yes.
cushion. So what do you think?
I think it's sound and also the diffusion.
Okay. So can I ask how do you define a large cushion? How do you define large?
I think because bigger than.
It's okay. So what about you? What do you think?
I think it's a very controversial question, and I don't think that really is a problem statement, since large can be different for everyone.
Okay. So since you said it's mainly projectile motion, do you know that there is a point between these two distances that the catapulted angle would be vertical? Oh, sorry. Thank you. I'm the reviewer for problem number 16, and I'm from Team Arrangers. And so this is the report. So what is this? Her proposal is that she had a clear hypothesis, clear theory, and good time management, and also considered several parameters. But then some of the improvements are human error during the experiment. Then error bar is not really that obvious. And then she didn't do what the problem statement wanted. And then this is what about the opponent, great analysis on the report and nice understanding of the experiment, also knew a lot about the theory, and then he asked a lot of crucial questions. And then, but I think he can focus more on the data and maybe the reverse data or the theory rather than talking too much about his own theory. And then he had lack of correlation between the opponent's view and the reporter's data. So this is the improvement. And then some of the missing points that I think they have. Common statements mentioned several other objects, and then what I see in those experiments are only one drop and one catapulted. So I think this is one part. And then they didn't define what is a large error. Also, they should focus more on their experimental results. Okay, so this is some questions that the opponent asked the reviewer. So did she consider torque? And the reviewer said no. And then the reviewers think that it should be considered. Also, size of bag. The reviewer didn't consider it. And then the reviewer also think that it should be considered. And also, the opponent asked about the rebounds of the object. And then the reporter didn't consider, but the reviewer thinks that it can be concluded as the energy loss. And then they consider, did they consider different shape of object that is being catapulted away? And then no, but they know that they use a round object. And then the reviewer guesses it might affect the angle of catapult if you use different shapes of object. And then the opponent asked, did they make sure the string doesn't move when they cut it by scissors? And then the reporter said that it didn't move, but then the reviewer think they can use a pulley system, and then maybe it will be more stabilized, so there will not be like moving. So did they quantify the energy loss? And then the reporter said no, and then but reviewer think that they can be quantified by work energy principle. And then, so this is what I asked the reporter and the opponent. So did they only drop one object? Then the reporter said yes. I didn't ask the opponent. And then the reviewer think that they should consider the problem statement. Also, error bar too small or having none, and then the reporter too small, and then energy loss should be 25. So I also asked about the main factor of this experiment, and then the reporter thinks it's the gas volume, and then the opponent thinks it's the mass, and then reviewer, I think it's the release height, because I did normalization, and then the analyst told me that release height is the biggest factor. Error resistance didn't consider it in their theory, negligible, and then reviewer thinks contact time, unclear unclear reply, and then opponent not asked. So yes, how to define large is different for everyone, and then the reviewer thinks that how to define large is large enough for a flat surface. Okay, thank you. That is the end.
Including remark, and when it's about this number, opponents and they actually cover about the actual topics, and I think it's because it's dropping time, which means that we did the external accurately so that the opponent didn't notice it. And second is the energy conversion and was already mentioned in my presentation, and that's just the reason why the external batch is different from the theoretical one. And the first one is that I didn't agree with the opponent that there was not real energy because in our investigation of the pattern of function and the object is much closer than the opponent thinks. And I hope the opponent can be more flexible in my theoretical model and discuss my presentation with me, and then let me finish my expression, and so that we can communicate and investigate more about this research. And for the response from the reviewer, I want to clarify that the definition of large emission is that the gas in it is more than 10 liters.
Okay, thank you. So it's time to question from our jury. Any questions for James? Please.
Did you think that the object shape is important? I would like to hear the opinion of you. Shape if I change it to the like a ball instead of the what you show is like the cylinder, right?
I didn't hear completely.
If we change your experiment change to the like ball like instead of the cylinder like the object, did you think will influence the what you the experiment how you solve? Yeah.
So I think it will change.
So which shape do you think is the better shape for those experiments?
I think the best shape is the circle. So I will need to do the experiment.
So I think that it might affect, but I don't have an answer that which is the most optimal shape, because I think different shapes it will like cause a different contact time when we want to apply impulse into our theory, and then so I think there will definitely be an like impact, but I don't have an answer like which shape is the most optimal now. Okay, that's my answer.
Well, I have two different insights. For the dropped object, I think a rectangular object would be the best, since when you drop the object, it will push the air like this in the same length. And also, I think the more important factor of the shape of the object will be the shape of the launch object. Since when the energy is transferred, there will be also rotation of the launch object. And the moment of inertia will be different if the shape of the launch object is different.
Yes, please.
So, did you consider changing the material of your cover, which contains the
Change the material of the cushion.
yes?
I think
Because I can somehow imagine, I don't know whether you see lots of movie before, let's say lots of Jackie Chan's movie. When he fall down, eventually the material itself must be, easily to observe the transfer energy. So that's also the reason I think probably it's because you use that material such that your theoretical prediction is quite far away from your experimental result. I'm also thinking like if you use somehow like the more flexible material as your cover, probably more, you will have a better agreement between your theoretical and experimental prediction. But it's just my opinion.
Any more questions? Okay, no more questions. Please wait. 6, and 5. Next opponent. We show it. 7, 8, 5, 8, and 6. Final score reviewer. We show it. 6, 8, 7, 6, and 6. Okay.